Hello dear students, myself Dr. Kapil Chaturvedi, Associate Professor, Department of Computer Science and Engineering, Sagar Institute of Research, Technology and Science, Sage Group Bhopal. Today we will discuss a Java topic, Java exception handling. So as we know that whenever we implement any program, there may be a lots of possibility of occurring many kind of error. Once a error is exists in any program, that program will not be executed. First of all, even not compile. First of all, we have to prepare a program with zero error, and we compile program. Um, in case of Java runtime environment will execute that program, that compile that program, and if there is no error in a program, compiler will compile that program properly and generate the bytecode. Once a bytecode generated, our program will be executed on the console by using Java command. What we see one more case, we face one more case when our program is error free. We properly compile our program, and when we go to execute our program, we see that many of times, and whenever any unhandled operation performed by our logics on runtime, so on that time our program will be terminated unconditionally. Abnormally termination may be occurred on that time. So to prevent such kind of termination of our program, and to prevent such kind of errors, we uh, uh, we use the exception handling logic in our program. And such kind of problems, such kind of errors which will be occur on runtime will be known as exceptions, Java exception. So as the official definition of Java exception is that the Java exception, the exception handling in Java is one of the powerful mechanisms to handle the runtime errors. So we discussed that the runtime error is known as exception in Java, so that normal flow of the application can be maintained. Exception handling is a mechanism to handle runtime errors such as class not found, IO exception, SQL exception, uh, index out of bound, remote exception, etc. Many kind of exceptions many kind of exceptions library are available in Java. Uh, there are a hierarchy which represent the different kind of exceptions in Java. There are two variety: exception and error. Error means which may occur on the runtime, or error occurred on the runtime, but with due to virtual memory issue or different kind of issue. But the exceptions, in exceptions category, there are some kind of exceptions like IO exception, SQL exception, class not found exception, runtime exception, and this is the variety of runtime exception. IO exception will occur whenever we perform or implement input-output operations in case of IO stream implementation. SQL exception may occur in case of whenever we implement JDBC programs in Java. Class not found may occur on such time when we invoke an object, but that related class is not available. And in case of runtime, in the variety of runtime exceptions, arithmetic exception, null pointer exception, number format exception, and index out of exception, there are the exceptions which will be occur. Arithmetic exception will occur when we perform any arithmetic operation, and we see that that operation is not normal. Like whenever we divide any number by the zero, we know that formulation will generate infinite number, and any programming language cannot handle infinite. So this is abnormal operation. Whenever that kind of operation will occur in our logic and runtime, arithmetic exception will occur. To handle such kind of exception, we use arithmetic exception. And the array index out of bound index of array index out of bound is another kind of exception which will be occur when we use a array beyond of the pre-decided size. For example, if we define an array of a of 4 size, it means we can use only 4 variables of that particular array from 0 to 3. What I want to use its fifth location, but we predefined only 4 space on the array, 4 block of an array. But on runtime, we want to store on a of 4. So on that time, array index out of bound error will be occur. So there will be some keywords which will be used in that exception handling mechanism: try, catch, finally, throw, and throws. So the try keyword is used to specify a block where we should place exception code. The try block must be followed by either catch or finally. It means we can't use try block alone. So before discussing that, I think we should have to see the syntax of the exception handling, in which we are seeing that we have to put such kind of statements which may occur exception inside of try catch block. So that is the block in which we put the statements which may cause exception. So that block initiate from the try and end with catch. So try and catch is the mandatory part of our exception handling mechanism. So that is nothing difficult here. We'll just have to put our code in that try catch block to handle exception handling. And the finally is a part, finally is a block is used to execute the important code of the program. It is executed whether exception is handled or not. In both of the cases, if exception occurred or exception is not occur, we want to execute some statement. So that kind of statement we will put in finally block. Throw and throws are the another issue. The throw keyword is used to throw an exception. We forcefully throw an exception. Basically, we use that in case we implement our own exception, we use keyword throw. And throws keyword is used to throw multiple exceptions. When we realize that our code may occur multi kind of exceptions, so we use keyword throws. The throws keyword is used to declare exceptions. It doesn't throw an exception. It specifies that there may occur an exception in the method. It is always used with method signature. It means we are not talking about the block of the statements, block of the code. We are talking here about the method. Whenever we realize that our method may cause multi kind of exceptions, so we use keyword throws. We more discuss on that keywords, and we more understand on that keywords programming. That is the syntax. Uh, as we discuss, try catch block, and we put block of code to try. It means we are putting here the code which may cause exception, and that is a part to handling code of our exceptions. So in case exceptions occurred, we use that part to handle exception. There is one. This is one example with finally. We discuss finally is a block where we put the set of code which we have to execute in case error occurred or not. Whether error occurred or not, we have to use such a statement. So we put that statement, that kind of a statement in finally block. So this is one example in which we are putting some set of code in try catch block which may cause exception, and here we are writing handling code, or we are simply printing a message. In case of error occurrence, that message will be displayed, and thereafter that code will be executed, and that will be the output of that program. There are one more example of exception handling in which we are discussing arithmetic exception. Arithmetic exception divide by zero. We discussed that whenever we divide a number by zero, then infinite will be resulting. We will get an infinite number. We cannot handle infinite number. So that kind of situation will occur exception, and that exception will be arithmetic exception, and specifically the exception will be the divide by zero exception. So simply we are creating a class, public class Java exception example. Inside of that we are making a main function, main method, and inside of that we are making a try catch block, and inside of that we are writing a code int data equal 100 by 0. So whenever we divide 100 by 0, we get data, we get infinite. That will be a finite number and infinite number and handling code we are writing here. So as a handling code we are printing a message and rest of the code. Okay, so this is one example. uh, let me go on the crimson editor so that we can run our actual program. So here is our program in which we are creating a class exe, and inside of that we are making main function, and here we are taking an array with size 2, where in the first variable of array position a of 0 we are defining 5, assigning 5, and in the second position a of 1 we are assigning 10, and we are taking another variable b equal 5. So e of 0 having 5, e of 1 having 10, and b equal 5, it means b having 5. And we are implementing that program for arithmetic exception in which we are creating a case, we are generating a case divide by 0. So we are putting here code a formula x equal e of 1, e of 1 it means 10 upon in bracket b minus e of 1, b is 5 and e of 1 equal 10. So in this case e of 1 is 10, 5 minus 10 equals to be minus 5, and e of 1 equals to be 10, so result will be minus 2. So there will be no error, so that program will print minus 2 with no error. So our control will not transfer on that code because there is no exception. Okay, so and we are writing some code in finally section, finally block, that is finally block, and we are putting here some formula. So either exception occurred or not, in the both of the cases finally block will be executed. We are going to execute that program, and when we see that, when we run that program, we see that the output is x equal minus 2, because we as we discussed that there is no error in that program, and operation is normal operation, so that will be print the output x equal minus 2. And here is the final block, that is the finally block, that is the finally block. Let me share the console, let me share the console. So this is the console where we execute the program, and we see the output x equal minus 2 as we discussed, and that is the code of finally block, that's the output of finally block, where we are writing a message that is finally block and y equals to be 2. Now we are going to make some changes in our program, and we are changing here e of 0, and when you solve that, manually solve that, you see that a equal 1, it means a equal 1 equal a of 1 equal, it means 10. So 10 upon b minus a of 0, so b is 5 and a of 0 is 5, it means 5 minus 5 equals to be 0. So here the formula equal x equal 10 upon 0. So that case will be occur an exception, that exception will be divided by 0 exception, which will be under in arithmetic operation. So we are handling that exception as arithmetic exception E, and if that error will be occur on runtime, that message will be displayed instead of printing the value of X. So let's go and execute that program by I save that program, and again I compile that program. So if there no error in that program, will properly compile. So that program is compiled properly because there is no error, and I am executing that program, and we see that divide by 0, that print the message divide by 0, because that operation occur an error. That error is divide by 0 error. As we discussed, whenever we divide one number with a 0, infinite number will be generated. So that will generate infinite number, and that will throw the control of the program on the catch portion, and catch portion will print that message that is divide by 0, and that is the final block. As we know that block will be executed either exception occurred or not. So this is our exception handling topic. There is nothing difficult. It is very simple. We will just have to put our statements in our try catch block, and handling a statement in catch block, and statements which we have to execute either exception occurred or not. In both of the cases, we have to put such kind of statement in finally block. So this is our exception handling mechanism. As we discuss our PPT, that example is a similar scenario we see in our example. So thank you so much.